Okay, looks like we are live. It would be good if from the audience if we get a thumb up if you guys can hear us. Thanks, Dustin. Thanks. Okay. Okay. Okay, so welcome everyone. My name is Mario. I'm developer at Astar, and I have the honor to have with me two great guys. They are Dagmar and Wouter. They are part of the Rooster Dao team. I met the team during the North America hackathon. They built a really cool project, and we approached them and asked if they can build the same using Swanky. And I hope that that experience was good for them. And this talk is really about them building this dApp and also using Swanky, but that's less important. So you will see all they know they will show today. And just to start a bit, yeah. So this is the agenda today. Okay, I introduced the guys. So we'll talk a little bit about RMRK and what's Swanky. We'll show you the architecture of this dApp, and we'll have a live demo with Q&A. Q&A is open for anyone. I hope it's open. So anytime you just guys on the bottom, try to find this ask a question, and then yeah, ask a question, and then just post it. Somebody from the team or me will answer, or later the guys who are presenting will answer. Okay, so I hope all of you know, but just a quick recap. If you can just make new slide, please. Okay, one more. Okay, so in short, what is Astar Network? One up. Okay, good. In short, we are hoping to become the innovation hub on. Okay, wrong slide again. We are trying to become the innovation hub, not just on Polkadot, but for Web3. What one of the special features that we have as Astar Network is the dApp staking, which is basic income for developers. So you to start a project, you build your project. You don't have to go immediately to VCs and get funding for your project. You can apply for dApp staking, and this is like network rewards for the dApps that are available, not just that are like voted for. So community votes if we can allow some of the dApps to become funded by the network. As you know, we also have smart contract support. We do support WASM and we support EVM. And we also build this cross virtual machine. It's still not public, but we are close to publish this as well. So now that we have a quite live EVM network and environment with a lot of applications using our EVM, we want to connect projects from EVM side and on WASM. So we made this cross virtual machine, but this is not a topic today. We will talk more about that in the coming weeks and months. Okay, next slide. I think that's just what is Astar Tech Talk. We started recently with this. We want developers, be it from Astar or any other developers, talking about the development and about their projects. This is really deep dive technical. So sorry if you cannot follow. This is really for developers. Yes, and we want to enable with this tech talks. We want to enable developers to build dApps on Astar and Shiden. So Dagmar and Wouter, maybe you can introduce yourself, and the stage is yours.
Thank you. So yeah, I'm Dagmar. I'm here together with Wouter. We are part of the Rooster Dao team. Yeah, maybe we can go and straight dive into the slides, or maybe Wouter, you can present yourself too.
Yeah, hello, I'm Wouter, or also known as Zebux in the Web3 environment. And yeah, I built RoosterDao together with the RoosterDao team and Dagmar.
So, yeah, what is Rooster Dao? Rooster Dao started during the New York hackathon in the summer of 2022. Yeah, we really had a lot of fun building it. And Rooster DAO is an investment fund that solely focuses on Polkadot infrastructure. And in order to be part of the investment fund or the investment DAO, you have to buy an NFT. And the basic idea of the NFT is that the NFT can change according to your behavior in the DAO. So, for example, everybody who owns the NFT can participate in proposals or in votings, and the more that you participate either in voting or proposals, the more your NFT evolves. Yeah, regarding the hackathon, it was our first time that we actually participated in a hackathon, and it was really cool to see an idea come to life. And we're actually in the process of building a company with a part of the team that we formed during the hackathon. So yeah, maybe this is a message to the developers. If you're doubting to participate in hackathons, we only can recommend it. Yeah, maybe we can go to the next slide. So about this NFT that evolves, we use the Remark protocol, which is really cool. You can see Remark a little bit like the Legos for NFTs. They have really a lot of functions that classical NFTs do not provide. For example, nestability. An NFT can hold other NFTs. The Remark NFTs, they also have like they can be like multi-source. So an NFT can be an image, an audio file, text file, and depending on which platform you use it, you can either hear it or see it. And I mean, there are more functions that I'm not gonna get into it, but it really helped us developing this this NFT that could evolve according to your participation in the DAO. Yeah, maybe the next slide.
Yeah, and we also used Swanky nodes, which is actually provided by Astar Networks. So Mario is much better suited than me to give a word of explanation on it.
Sure, just quickly. So Swanky node is part of our Swanky suite. We will release it in the coming weeks. It's really close to release date, not just the node, but also the whole suite. So more about this probably on the next Tech Talk. It is really built for the ink developers, so it includes the palette contracts, similar to Substrate palette contract. What is the node? Substrate node. What's the node? What's the name of the node that Parity provides? Yeah, it's similar, but also has some extra stuff like we build in the Remark palettes. We have dApp staking, and we are building also uniques. So your smart contract can also reach those palettes through chain extensions. And it also has an instant seal, so one transaction is one block, so you don't have to wait 2 or 6 seconds for the block to be completed. So that's really a tool for building contracts.
Yeah, and then so we did or reported RoosterDao to Swanky. So to give you an idea, or just like Dagmar explained, we had this idea to make a DAO where your membership NFT evolves given your participation in the DAO, your on-chain actions. For the first version, the one that we submitted for the hackathon, we added the remark palette to the substrate contracts node, and we added or rewrote during the hackathon the chain extensions necessary to be able to interact with the remark palette from the in contract. But then later on, and for this demonstration, we ported the RoosterDao contract to the Swanky node, as it contained everything we needed, and they had a more standardized version of the chain extensions, which was a good thing for functionality. If you look at the architecture, for which the scheme is done, given here, the schematic is given here. This is how it all interacts together. So we deployed the RoosterDao contract, the WASM RoosterDao contract in the contracts palette. From there, it calls or it uses the remark palette chain extensions to interact with the remark palette as needed, or the functionality needed by the contract. And obviously, any UI or other interaction with the contract has to go through the node. And then, we provided in the presentation our contact details. So if you try out RoosterDao yourself and you run into issues, do not hesitate to contact us. We'll be glad to help you out or to discuss the functionality of RoosterDao in case you would have questions or remarks. We also have the original RoosterDao GitHub repository listed here, where you can find the code as it was submitted for the hackathon.
Yes, I shared the presentation, so all the links, if you need it, are also in the presentation.
Yeah. So if there are no questions at this point, I suppose we can start the demonstration. I'll try to share the right screen. So for the demonstration. So what did I do to prepare the demonstration? I downloaded and compiled the Swanky node, and I just launched it. I just launched it with the dev option. I also compiled the Rooster contracts. It's provided, but you can find it in the presentation. It's provided on GitHub in the chain extensions contracts repository from Astar Networks. So I followed the instructions to compile the Rooster WASM contracts. And I also set up the UI following the instructions provided there. And important, I copied the contract metadata that was generated during compilation phase to the UI. So here we are. We have a clean and mean Swanky node. It just started up. And to be able to use the UI that we provided for Rooster, you need to instantiate or to upload and instantiate the contract once to allow the UI to find it on chain. So that's what I will be doing now. I go to the developer contracts section of the Polkadot Explorer, and I provide the WASM binary that I compiled before, as you can see here. Okay, and then it asks here to provide values for the contract constructor. I will just leave them as a default for now. The next step, we will be using the UI to instantiate the contract once again, and then we will provide more meaningful values for these. So I just walk through these steps. And I submit this. As you can see now, here the contract was stored and instantiated, and you can already have a look at the at the different functions the contract exposes. If you were wondering where we got all this, or we got inspiration for this, the functioning of this DAO is actually heavily based on the Open Zeppelin governor contract. So as some of you might know, Open Zeppelin is the repository for Solidity contracts. They provide quite a lot, and we took a very good look at their governor contract that they provide. With this understanding that we are using an NFT as the membership token for the DAO, RMRK NFT, to be more specific. You can also interact and perform all operations on the contract from this interface.
Sorry, Walter.
Yeah.
Can you just please zoom in a bit? Just Control plus twice. That would be good.
Something like this. Is it better?
Yeah. Much better. Yeah. Thanks.
Okay. So yeah, as you can see, the different functions exposed by the contract, you can call them from here if you want to experiment with it. You just need to transfer some tokens to the contract, and after that you can call the functions from the contract, just like the UI will do in an instance. But this is quite interesting for investigating how the contract works and to get familiar with the functioning of it. So, okay, that's it for the Polkadot Explorer for now, and I will switch to the UI to show you how it works. If all goes well, you can see the UI. Maybe I'll zoom in a bit right away. Okay.
Yes, it's so good.
Okay, excellent, thanks. Here you can see the UI that we made for this project. It's based, as you can see, on the Parities contract UI. We started from the Parities contract UI, and we added our functionality to it, and it allows you to switch developer accounts easily. So it's a good approach to have a first version of your app or your UI made in. And also, for the functionality that we're trying to implement here, the contract was based on Open Zeppelin. For the UI, we took a lot of inspiration from Tele XYZ, and it's a well-known platform to manage your DAO, and we actually copied most of the functionality that we found there. So okay, let's do this. Let's make a DAO. So when you click Add DAO, you see actually the same parameters than the one that you need to provide for the constructor. A bit more user-friendly presented here. You can see, for example, the different timings can be specified. The time that the vote will be open, or the delay before and after the vote is specified here. And also the price is here is specified, the price that members would need to pay to mint the NFT and thus become a member of the DAO. So, okay, let's create it. Okay, so it was the acting account of Alice that created that created the DAO, and thus she automatically becomes the first member of the DAO. For example, if another user, let's switch to Bob, wants to become a member, he can do so, but he needs to transfer the number of tokens to the contract that we specified during instantiation of the contract. So let's have Bob become a member of the DAO. And now we can see Bob is a member, and we can see the representation of his NFT here. Just like with the Open Zeppelin governor contracts, to be able to vote or to submit proposals, you need voting power. And how do you get voting power? Somebody who is member of the DAO can delegate his voting power to somebody else. You can delegate it to yourself, or you can delegate to somebody who you think will represent your opinion in the upcoming votes. So let's have Bob delegate to Alice, which is done now. It's an on-chain action that's happening now. And for example, let's have Alice delegate her voting power to herself. If we scroll down and we look at the voters, we see that Alice now has a voting power of 2, and Bob, he has no voting power. The fact that Alice has voting power allows her to create a new proposal, which we will do now. So by creating a proposal, she can obviously provide a name for it. And then we arrive on a not yet implemented part of the application, the actual transactions that will be executed if the vote is successful. It cannot yet be supplied. That is part for the future development of it. So for now, it's just the title that can be provided. So Alice provides the title, she creates the proposal, and now we can see that the proposal is active. We can see the timeline it follows. It will follow on the right of the screen. So as we took a 0 delay or a 0 pre-vote delay, voting is open immediately. This means that at this point, Alice can cast a vote for this proposal. She has decided to vote in favor of this proposal, and now she used her voting power and she submitted her vote. When we go back to the main screen for this DAO, we see that a new button has appeared, see available evolution. This is because Alice has participated in the vote. She brought something to the DAO, and she is now entitled to this evolution, and she can get it by clicking evolve. Same is the case for Bob, because although he did not vote himself, the person who he delegated his vote to did vote. So this counts as interaction from Bob with the DAO, and also Bob, he is entitled to the next evolution after this. So we see that Bob also has a second evolution. Let's go back to Alice. Let's have her create a new proposal. Which she did just now. It's also immediately open for voting. Let's have her voting again. She goes through some kind of identity crisis and votes against her own proposal. But even if she votes against, she has participated, and she is allowed to see another, to have her NFT evolve once again, thanks to this vote that she just casted. Okay, here we arrive at an interesting point. The images that you see here for the different roosters, the evolving roosters, they are fetched from IPFS, And yeah, for the production version of RoosterDao, we'll need to figure out, I suppose, a better way to fetch images from IPFS, because now we do it directly from the application, and more often than not, it fails. So yeah, we don't get to, from time to time, you don't get to see the evolution right away. It might load the next time. But yeah, the images fetching from IPFS, that's something that we learned is not always working very well. So Alice clicks on evolve. She is now has the third level of her NFT. We can go and have a try and see if Bob is more successful in seeing his IPFS evolution. No, it's not working. But yeah, Bob as well is at the third level now, and I will create one more proposal so that we can have Alice at the fourth and final level, or the currently final level that we have there. Let's have a vote and make her abstain this time, which she did. And let's see if we have more luck visualizing the fourth evolution. No, once again, you have bad luck. But the IPFS, the IPFS request somehow, sometimes it fails, sometimes it works just fine. So yeah, like I mentioned before, we will need to put some extra attention in showing the IPFS or the images that we fetch from IPFS. Yeah.
Perhaps you can just leave it. It will come eventually, right? We can show it later.
Yeah, yeah. Yeah, we will need to look at this, but maybe it will come through, or maybe it won't. So
okay.
yeah,
sorry. We have a answer. I think this is Yuri. He is saying that private IPFS gateways usually help, so that might be one of the ways to go.
Yeah. Yeah. I suppose that it was, yeah. I suppose that using the right gateway or not using a public overloaded gateway might definitely help in providing the extra functionality here, or the better functionality here. So yeah, that was actually basically it's the basic or the demonstration for RoosterDao. So
before we go to the code, is there any questions? If there is, please ask a question. Meanwhile, I have a few questions. So guys, if you can just explain how you approach the NFT evolution, maybe that can be interesting to someone who did not see how Remark works. So what did you use for the evolution?
So for the evolution, yeah, we during the hackathon we did quite some investigation and research. What would be the best way to perform the evolution, and we quite fast fell in love with Remark and all of the different functionality it provides, because it's really an answer to this use case we have here. So to be able to evolve the NFT, we use Remark NFT, where we add and remove resources to be able to have it evolve. So actually Remark provides a lot more possibilities and options there. So the evolution can be more fine-grained, or the options are actually limitless, but yeah, we just add resources to the Remark NFT at this point to have it evolve.
Okay, thanks.
Yeah.
Sorry, yeah. One more. So let's say I want to build a new DAO, and when I'm doing so, there will be the same contract instantiated again.
Exactly. Yeah. So yeah, that's true. So this is the really neat feature for the contracts on substrate nodes. You deploy or you store them once. You store them once on chain, and then you can instantiate them many times afterwards. And that's what's actually happening here. Or the UI expects the contract to already be stored, that the hash is available on the node. And then afterwards, when you click add DAO, what's happening is actually that there is a new instantiation of the contract made from this original hash. So you can instantiate it as many times as needed once deployed.
Okay, thanks.
Okay, I don't know if there are any more questions at this point.
Okay, so we have a question from Ilya from the Remark team. Any plans using equipable NFTs?
Yes, yeah, or like I said, the Remark has really a lot of options, a lot of possibilities on manipulating the NFTs and to be able to have a more fine-grained evolution of the NFT. The equipable NFTs are definitely an option. At the time of when we initially developed during the hackathon, it was quite, how to say, we needed quite some research and trial and error on the chain extensions. So we intentionally kept it basic just to make sure that we will be able to show something at the end of the hackathon. But yeah, as mentioned, there are so many options with Remark, so definitely it would be a good idea to use them and have a more fine-grained evolution of your NFT and more unique NFT as well.
Yeah, maybe to add on this, I feel that we need more examples using Remark like this, like your project. So Ilya, if your team can work on more examples using smart contracts, that would be really useful, be it on EVM or Inc.
Yeah, and yeah, don't hesitate to contact us if you need any or stuck at some point. It was quite some, as I mentioned during the hackathon, quite some research and development. So if you're stuck, don't hesitate to reach out, and we will be glad to help if we can. Okay. I don't know if there are no more questions at this point. I suggest we go and have a look. I will go through the repository where you can find all this and show the instructions how to recreate this example we just have shown.
Sure.
Yeah, so like we mentioned, you have the chain extensions contract repository on GitHub where you can find all this. The Rooster contract as well as the Rooster UI can be found under the examples. The Rooster contract is the Inc contract, obviously, whereas the Rooster UI is the UI and contains all the instructions that we that you need to follow to be able to perform all the actions that we just have shown here. Yeah, it should be not too hard to follow those, but like mentioned, if you run into problems, do not hesitate to contact us. And yeah, why not? Let's have a little look at the Inc contract because for our hackathon
Please
or
zoom,
for
just zoom.
Is this better?
Much. Thanks.
Okay. Yeah, the in contract is the core of the application with how to say yeah, or a few very interesting functionalities. The one and the how to say which one we spent during the hackathon afterwards most time on was actually using the chain extensions, which allow a contract that yeah, allow a smart contract, be it EVM or Inc, to interact with the pellets that the chain extension has been written for. I don't know. I must be honest. I didn't prepare the going through the code in detail. So I might get lost if I try to point out the interesting parts of it.
Maybe just show us like instantiation of the contract. What is there, and how you deal with this, or maybe after that also how you connect to the chain extension.
Yeah. So okay, the instantiation it's the constructor that you will call. We've seen it passing by on the screen quite a few times. Once in the Polkadot.js and once in the UI. You saw where the you saw these parameters being mentioned as well. And then, like I explained, we try to stick as much as possible or as close as possible to the Open Zeppelin implementation of the contracts. But whereas the Open Zeppelin, they interact with another contract to manipulate the NFTs or the governance tokens or the governance NFTs, we needed to interact through chain extensions with to interact through chain extensions with the remark pellets. So, for example, if you look at the function where somebody can mint the NFT or to become a member, you can see the yeah, the logic here. Some hard-coded IPFS data, but the actual call through to the via the chain extension to the remark pellet, you can see happen here, and this is through the crate containing the chain extension that we included in the contract, and this crate is provided as a part of Swanky node. So, for example, here you see the contract minting the NFT, the chain extension call for the NFT, and I suppose we can see the other calls to the chain extensions. For example, here we have the create collection, and here you can see us interacting with the resources to make the actual evolution. So here you can see how we do it. Every evolution, or when an NFT goes up one level, the previous resource was removed and the new resource is added, and that's how we perform the evolution of the NFT.
Cool, thanks.
Yeah, that is it. We only call for we only do 4 interactions with the remark NFT. At this point, we mint it. We create a collection, we mint inside it, and then we add and remove. We add and remove the resources on it, and that was all we needed to be able to have the evolution of the NFTs as shown in the demonstration.
Okay, maybe I can add that. So if you want to do the similar or same, Astar team prepared this chain extension, so you can go into a remark folder next to the Rooster Dao folder, and you will find all the calls that are available for similar. Yeah, here in examples, you will find remark, and then you can just scroll a bit up. Yeah.
Yeah.
So there is also a red spot test for it, so you can see how it's tested. Although at this point, I need to say that this is now broken with the latest update of Polkadot. So at the moment, red spot is not working on the latest and greatest node. So I'm just curious, Walter, which node you use, which version of the Swanky you use for this?
For Swanky, I used the most recent node. I just downloaded it and compiled it. But when I'm having the same problem you described with red spot. And actually, yeah, I was the testing. If you want to do the complete end-to-end testing nowadays, it's not so easy. If you want to run it from TypeScript, I've been actually busy this weekend writing some more TypeScript, yeah, or small red spot-like solution to be able to test from TypeScript scripts, because I feel it's missing. I don't know if something is on the way there.
Yeah, it's there are more things on the way. Not really from the red spot team, because they disappeared some time ago. But Astar team is building a Swanky suite which will also contain the testing capability. So expect this very soon. And also, meantime, if you want to build something, Swanky version 11 works okay. So this is still old Polkadot version. I think it's .28. Thanks, Pierre. And that still works with the red spot.
Yeah, yeah. Okay, yeah.
Okay, we have a couple of questions. So let me see. When will Remark be available on mainnet? That's, I guess, for me. So the palettes that we have today and that Remark team is building, they will not be anytime soon. But a reason for that is it's still not completed design and development. It still needs some tweaks and audit, because including it on a mainnet has a big responsibility for us, our team. So we'll wait a bit more, but we will enable developers to build meanwhile. And maybe also good to mention here, we are building together with the Remark team. We are building Inc. version of Remark. So you will not need to have a node supporting the Remark palettes. You could just take the Remark contract and deploy your project. So if you are interested to join the development, please contact me. We will soon publish this, so we will make it available for public to join and help in the Inc. development. Okay, then we have, are you coming to Solidity? Oh, okay, that's for you guys. So are you coming from Solidity background? If yes, then how was the switch to Inc. and porting EVM paradigm over? Is it less constrained or same caveats apply, like gas, contract size, reentrancy and stuff?
Yeah.
That's from the Remark team.
Yeah. Okay. I cannot say I have a very large background or a lot of experience in Solidity. I did start Solidity before I did Inc. But as I did several programming languages, or I've been programming for many years, it was not too hard to learn them both. I did have some Solidity experience, and yeah, I liked the Inc. environment a lot, and somehow naturally kept working in it. There are a lot of pages on the internet comparing both, and I will leave it to the experts to see where the differences are. But yeah, programming Inc is very nice and has been very interesting, an interesting thing to learn. Yeah.
Thank you. One more question. Do you know any self-study platform like Crypto Zombies for Solidity to learn to code the ink in ink?
Oh, I don't think that there is an equivalent of Crypto Zombies, so I don't know about it. But that there is, yeah, from my point of view, I maybe have your own opinion, Mario. But from my point of view, there is a lot of material. You got the open brush, which is very interesting. But yeah, the ink documentation by itself gets you quite a long way, and that was where most of us for RoosterDao, when we started RoosterDao, most of us did not have a lot of ink experience, learned it from.
I can add that ink is really not anything special. It's just Rust. So the way to go is just find, there are many courses and tutorials on Rust. So just learn Rust. Once you know Rust, ink is really nothing new. You just use it. Okay. So yes, please proceed. We are done with the answers for now.
Yeah, but for I'm also done with my part of the presentation. So I don't know if there are any more questions or topics somebody would like to discuss.
Yes, let me ask you about the UI. So how difficult or how simple would be to reuse the UI that you guys made? I saw that this is basically made from Contract UI platform, right?
Yes, but to be honest, I was another member of the Rooster Dao team that did most of the implementation there. So it was Predrag. I don't know if he's present. Maybe he can raise his hand. But it was another member of the team that did it. And yeah, it worked out pretty well. The thing is that during the hackathon, it took us quite some time, or most of the time was spent on the writing the contract, and the front end could only be developed in the last few days of the hackathon. So we put a lot of pressure on him to deliver in time, but he did so, and this was the result. But I cannot estimate the complexity of what he did. But I suppose it's a good approach to start from the contracts UI and start working on that.
Okay, cool. At this point, we have quite a few Remark team members. So, guys, if you want to raise your hand, I can put you on stage, and if you can say just a few words on the current state of Remark development. So let me know if you want to come on stage. Ilya or Yuri? Okay, we have Yuri. So let me connect, bring Yuri on stage. Yuri, 1 sec. Here. I think Yuri, you just need to accept the. I can do it again. Okay, welcome, Yuri.
Hey.
This was not scripted, so thanks for coming.
Yeah. No, it's really exciting, and especially ink, because we do believe ink is the future. But and even Gavin said, and many say this, and it's obvious that ink is the future. But the Solidity is current, present. We're focusing right now on Solidity mostly, and Rust developers are really hard to find. So by community building this, it's very helpful, and we can later join in to help out and test and finish it with our experience from Solidity contracts, because they're nearly ready, and there are a lot of kind of some caveats and some issues that people need to be aware of, especially around nesting. That can be expensive to call, to update a tree of children if you burn parent, for example, and things like that. So we're trying using different tricks for that in Solidity, and I guess most of them can be ported to Ink because principles are similar there. So yeah, but yeah, it's really cool. I know nothing about Ink, to be honest. Never tried any tutorial or anything. So, but I'm excited about it, and yeah, I think this will be the future eventually.
Okay, cool. Can you give us like some like status of the project if you have something to share?
Yeah, so in the past year, we've been heavily focusing on Solidity contracts, building a team. We started in the middle of bull run, so it was difficult to find any devs because everyone was working on some big DeFi projects. But now we have a team of 4 Solidity developers in-house. The contracts are basically ready. We're just doing some security passes. We submitted it to EAP now, which was kind of, it's assigned a number. It's almost, we've got some comments, but it's almost accepted. Yeah, so we're just doing last polish, but the main work now is on UI. So we're building the marketplace that can support both our alt implementation and Solidity implementation and palette implementation in future. So we're refactoring.
And of course, Ink.
Yeah, of course. So basically we're rewriting code, so all the components doesn't care where the data come from. So then we can plug different implementation, including Ink and palettes and Solidity, and just reuse the same UI for all of them. And we'll be open sourcing some of it. So yeah, that's the current state.
Okay, maybe I'm just curious. You might know in the .sama ecosystem how spread is the RMRK palette, and RMRK as Ink. I know that Gear has their own implementation of. So if you can give us like a little overview to your best of your knowledge.
Yeah. So the palette version is. So the Solidity version will go beyond .sama, obviously. That's the plan with it. But within .sama, it's Ink and palettes. Palette, so Fala obviously is using it. It's the biggest, I think, the project that is using it. They're one of the biggest supporters of it in code-wise, as well as Astar. So they're using it on Fala World. They had a mint event today. And another one is Invarch also, who are planning to use them in their IP NFTs. So like intellectual property, they have intellectual property Parachain, where they can use nesting there. It's, as I said before, it's very hard to find Substrate developers. They're just a handful of them. So we were struggling to find someone. So we were relying on open source contributions from teams like yours and from teams like Falas. And only recently we found someone we can pay actually to speed up the progress. So now, in addition of all the great open source contributors like yourself, we also have someone who is doing it as a paid job. So now it's progressing. We have some activity on very difficult PRs around nesting and this budgeting, how to budget the recursive calls. So hopefully the difficult parts will be finished soon, and we can move to kind of next final steps of polishing them. And benchmarking, of course, which you provide the most. So which is no other devs want to touch this part because it's complicated and big and annoying also, and not very glamorous work. But
I'm happy to help.
Yeah, it's amazing because everyone is afraid to try benchmarking. So thank you very much.
Okay, guys. I think we are at 1 hour limit. Yuri, thanks a lot for chipping in. That was really cool. Dagmar and Wouter, thanks, guys. I think this was really useful, so people get ideas what can be done in Ink, and they have also some examples, so they can try. So thanks, everyone, and
thanks for having us.
Sure.
Thanks for building it. Very cool examples there.
Yeah.
Thanks. It was a pleasure.
Yeah, but you didn't say that you won quite a few prizes on North America Hackathon, right? It was also financially good, right?
It was quite lucrative. We won second prize in the DAO category. We won the public prize and also a remark bounty. So it was not too bad. It's not only technically interesting to participate in the hackathon, but you can get something out of it as well. And right. I'm about to receive a lot of Polkadot swag someday soon. So
Cool.
That's also very nice. Yeah.
So this is also an invitation to all developers to try out and struggle a bit and learn a lot, and it's worth value in tokens or money as well. So
yeah.
Okay, guys. Thanks everyone for joining. See you in 2 weeks or so.
Thanks a lot. Speak to you later.
Bye.
Thank you.